All right, so the ambiguous case. We've explored the law of sines and the law of cosines, but when we did problems, we did very specific problems that always worked out. And now what we need to do is explore this ambiguous case, this weird situation that might occur, and then how do you deal with it? So first of all, if you think back to geometry and think about all the different ways that you had to prove triangles congruent, we had side, 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 angle, side, angle, 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 side. We had all these different methods. And what I want you to kind of do, we're going to list these out so it looks like we're proving triangles, but it's really the information that's given to you. So for example, the SSS means that you are given the three sides of the triangle. The SAS represents that you're given two sides of a triangle and the included angle in between the two sides. So if this is the given information, either of these two scenarios, you are going to use the law of cosines because that's the only way you'd be able to solve it. Okay, and that's what you saw in the assignment. Those were the two different scenarios that you were given, and it will always work out. For the law of sines, the three different options that you could have been given were two angles and then a side. You could have been given the two angles and the side is included in between the two angles, or you could have been given two sides and one angle, and then you could have solved for another angle, right? So if you look, these four, side, 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 angle, angle, side, and angle, side, angle, those four are four different reasons that we could use to prove triangles congruent. But this one, this last one, SSA, if you spell it backwards, it spells backward, right? We were not allowed to use in order to prove triangles congruent. Well, that is the ambiguous case, because sometimes they do give you two sides and an angle. And sometimes you can solve it, and you'd have to use the law of sines in order to do it. But there's occasionally times where the information, the two lengths of the sides and the angle that they've given you, don't give you an actual triangle. Or perhaps they give you two different triangles. And so we need to take a look at those situations. So that is the ambiguous case, when they've given you two sides and an angle that is not included between the two sides. Okay, so we're going to go through a checklist, the steps for checking how many solutions you're going to have if you encounter the ambiguous case. So step one, first thing you're going to do is you're going to check to see if your angle is acute or obtuse. And once you've figured that out, then we're going to go into two different categories, right? So you do these steps if it's acute, do those steps if it's obtuse. So after you've checked if it's acute or obtuse, the next thing you're going to do is you're going to compare the side A with side B. You're going to see which one is bigger. Okay, and so based off of that, then it'll give you the total number of solutions that you'll have. So let's take a look. Okay, so say your angle is obtuse. Say you get an obtuse angle, something larger than 90 degrees. Remember, the next thing you had to do was check to see if A is less than B, or if A is greater than B, or if A equals B. Well, if A is less than or equal to B, you get no solution. There's actually no triangle in that case. And this is what it would look like. If you have an obtuse angle, and then this side length, which is opposite angle A, is shorter than the side length that's opposite angle B. This is side B. So when that happens, this isn't long enough to actually extend down to become a triangle. If it actually equaled B, it would go right there. It still wouldn't make a triangle. So that means that if A is greater than B, you get one solution, which is your obtuse triangle. And then you continue on, you solve as we did previously. So it's really nice when your angle is obtuse, because then all you have to do is check if A is less than B or if A is greater than B. You have no solution or one solution. If you have no solution, you're done. You don't have to solve anything, right? So that's always nice. All right, so what happens if your angle is acute? Well, the next thing you're going to have to do is check if A is greater than B or A is less than B. So if A is greater than or equal to B, we get one solution. There's our triangle. Here's my acute angle. Here's side length A, bigger than side length B. We get a nice, beautiful triangle there that we can solve. The trouble comes when A is less than B. So if A is less than B, you have a third thing that you have to do. You actually have to calculate the number. What is B times the sine of angle A? So figure out what that number is, and then compare that length with the length of side A. And on the next slide, we'll take a look at what happens when A is bigger than this, when A is equal to this, or when A is less than this. Okay? So let's take a look. So if your angle is acute and A is less than B, you've already calculated B sine A. If A is less than B sine A, you don't have a solution. The reason is that B sine A, what you're doing when you calculate that is you're actually calculating the height of your triangle. And if you recall, we looked at that when we derived the law of sines. So B sine A, you're looking at the height of your triangle based off of this angle and this side length, right? And if side A is not long enough to actually touch down to AB, then you don't even have a triangle. So if A is less than the height, no triangle, no solution. Now if A is equal to B sine A, you get one solution, you get a right triangle. So if that's the case, that's really nice. Okay, and then the third option is if A is greater than B sine A. And this will give you two solutions. And you're probably wondering, like, what? Two solutions? Well, there's two different triangles that could be created with the angle A, side B, and side A. So here is one triangle. Here's that side, and that side. So there's one big triangle, right? But there's also another triangle that we could have done. Close, go away. And that would have been this side. Here's side A, and we have our angle A. So there's two different triangles that you can get. You can get the yellow triangle, or you could get the blue triangle. And they both have the same given information. We both have angle A, we both have side B, and they both have side A. It's just a matter of the fact that the side length of A and the relationship with this angle is just in the perfect scenario that it could create two triangles. Okay, so if you have no solution, you're done. You don't have to do anything more. If you have one solution, then you solve that triangle for that one solution. If you have two solutions, you actually have to solve for every single option for both the yellow and the blue triangle. So let's do an example where that works. Okay, so here we go. In this scenario, look, we have an angle and we have two sides, and the two sides that they've given us are not surrounding angle A. When we draw our triangle, and I would suggest you definitely draw your triangle just so that you can keep track of everything, please make sure that your letters are in the right place, okay? And distinguish between angle B1 and angle B2, or these 2 points specifically. That way, when we start talking about the different triangles, we can keep track of them. Okay, so let's test this out. Let's go through our checklist. First of all, is A acute or obtuse? Well, it's acute. So the next thing you do is you compare A with B, and A looks like it's less than B. So if that's the case, then we have to calculate B sine A. So calculate B sine A, we get 7 times the sine of 42, which gives me 4.68. And now you can see that A is larger than B sine A, and therefore we have two solutions. But we already knew that because I designed it that way, right? Okay, so the first thing you're going to do, remember we're doing law of sines for this, is we're going to use the law of sines to calculate this angle right here. So we work that out and we get angle B1 is 69 degrees 30 minutes. Remember to convert this to minutes, and in these problems you're going to round to the nearest 10 minutes. So this really, if you do this on the calculator, comes out to be 31 minutes. But we're rounding down to 30. Okay, so what we've done is we've calculated this angle right here. So the next thing that we're going to do is we need to calculate the other option for angle B, which would have been this angle right here. And if you remember, this is A and this is A, so we end up having an isosceles triangle So by if sides then angles, this angle is the same as the angle we just calculated. And then this angle and that angle are supplementary. So we just have to subtract from 180 in order to get angle AB2C. So remember to convert 180 to 179 degrees 60 minutes. So there's angle AB2C. Next, we need to figure out angle C. Well, there's two options for angle C, right? There's this big angle that would have been part of the yellow triangle, the big triangle, and then there's this little triangle or little angle right here. Okay. So let's solve for angle ACB1. So to solve for this big angle up here, we're going to take angle B1, add it to angle A, and subtract it from angle A, or from 180 to get angle ACB1. So 180 minus taking this angle and adding 42, we get that angle. And we get 68 degrees 30 minutes. So angle ACB1 is 68 degrees 30 minutes. Next, we can't do a fancy little trick like we did over here because these angles are not supplementary, but I can take this little angle, or I guess it's a bigger angle, huh? It's obtuse. We can take this obtuse angle and angle A, add them together, and subtract from 180. So taking this angle down here, adding it to 42, subtracting it from 180, we get 27 degrees 30 minutes. So angle ACB2, this angle right here, is 27 degrees 30 minutes. So notice that a lot of these calculations are just a matter of adding and subtracting angles, right? All right, now the next thing that we have to do is we have to figure out what this length is, because that's the side opposite angle C, so that would be one of the C lengths. But then we also have to figure out this one. Okay, so those are the two that we need to go for. So to figure out this, we're going to go back and use the law of sines, because we can do 5 over the sine of 42 is equal to this length, AB1, over the sine of angle ACB1, which we just calculated is right there. So I can set up that law of sines. 5 over the sine of 42 is equal to AB, which we don't know, over the sine of 68 degrees 30 minutes. Now this is why having a diagram, marking things, labeling things is going to be really handy, so that you definitely plug in the right thing to solve, right? So when we work this out, AB comes out to be 7, because this was 6.95. We're going to round to the nearest tenth for the side lengths, and so that 5 rounded this up to a 0, so we're at 7. Okay, so to finish this off, we just have one more piece that we have to find, and that is this little one right here, AB2. So this time, this angle right here is going to be this little angle that we just solved for, which is right there, 27 degrees 30 minutes. Plug that in, we solve it, and we get AB2 is 3.5. Whew! Wow, that was long. There is a lot of work when you have two solutions, but that's okay. It's not too bad. Just keep track of everything and don't get lost along the way. I would definitely suggest labeling things, making sure all the letters and subscripts are correct. All right, there you have it. Good luck, folks. See you later.